Okay, this is a little extension for the situations where people think probabilities are equal, but they're strangely not. Here's some simple spinners. These all have equally likely outcomes unless somebody's actually faking it. So that first spinner, the probability of the purple is going to be 1 out of 1, 2, 3, 4, 5, 6, 7, 8. First spinner, number 1. The probability of purple is 1 section out of 8. Number 2, probability of blue is going to be 1 in 2. They all look the same size. And the word is, what do I mean by size? This is the question. Size here is a little bit different to what most people think. And we'll look at a couple of little examples in a moment. So number 3, each of the sections are the same size. So the beige one, remember right, is 1 out of 16. I think there are 16 colours going round. Yeah, they're in sections of 4 in each quadrant. And number 4, straightforward, probability of yellow. Now this is assuming that there's no fudging going on with how the spinner works, where it goes to. We're just saying, just looking at that as it stands, this is the probability of things to happen. That's what we did in the first video for this lesson. Now this video, we're going to discuss some slightly different sections. So here is the probability the same for the green, red, orange, purple, yellow. It's quite obvious that this green section is so much bigger that the probability of green, if it is obvious what the angle is, you can normally assume an exam question is saying it is the same. So this is half of the circle, so the probability of green is a half. So that means that each of these 4 sections make up another half, so the probability of red should be an 1/8. And so is the probability of the orange, the purple and the green. And actually what you should also realise is the probability of all colours is going to be 1. Then it's certain that one of these colours will come up. So if I told you on this one that the probability of red, yellow and blue is 2 out of 3, red or yellow or cyan is light blue. If I told you that was 2/3, oh, 2/3, not 3/3, what would the probability for the blue being? And it's going to be whatever is needed to make this value up to 1. So it's going to be 1 minus 2/3. You can either grab a calculator or use your fractions practice. 1 as a common denominator of 3, going to be 3/3 minus 2, gives me an answer 1/3. So the dark blue is what probability of 1/3. Now the second one, we look at the sections. Well, blue's definitely, dark blue is bigger. So the dark blue in this one is now bigger. Does that mean that it's got a greater probability in this question than in that one? So just look at them. It's a bigger section. Does it have a different probability? If I told you all I've done is I've rotated the 2 pictures and enlarged the second one, you'll probably realise quite quickly that this must have the same probability. And with spinners, probability comes from the angle. The size is the angle size that makes up a spinner, not the area. So this is one of those things that causes a problem for a lot of people, is they make a mistake in that they think the size is how big the area is. And it's common for your eye to get drawn by areas. As we did things in statistics, I did mention that one way people fudge graphs, especially pie charts like this, is they will twist it, turn it so that there's a section closer to you. Visually, it takes up a bigger area. So they'll often make mistakes just basically based upon how big the area is, not the angle. So if we go back up to here, if you were to get a protractor out, the angle for this is 120 degrees. So you could actually done the same calculation here. The probability of dark blue is its angle compared to a full circle. So this angle there is 120 degrees. Hopefully you can all see that and estimate the angle as being about right. Divided by the full circle, 360 degrees, which gives me 1/3. If you have a look at the red and the yellow sections in both of these, they're both 90-degree angles. So we can now say the probability of yellow and the probability of red. I'll just move this next section down a little bit. So just move the section down. So we could actually work our way through and use this to solve a few other problems to do with this spinner. So the yellow and the red are both 90 degrees. And we can use that to work out the light blue probability then, which is clearly the smallest. So the probability of dark blue, red or yellow is the angles for each of them. So dark blue is 120, the angle for the red is 90, and the angle for the yellow is 90. And this gives me a total probability of 360, which tells me that I have a total angle there of 300 to 360. And if I want to work out the light blue, I can do that as a 1 subtract what's needed to turn 300 into an angle of 360. So we get 360 minus 300 all divided by 360. Now I'm not saying all this stuff is what you would write in your answer, but it does underline what we're talking about and how the angle links to the light blue. So overall both of these will cancel by 10, so it's 6 over 36. Again, it will cancel by 6, so it's 1 out of 6. And if you take the 1/3 for the blue section, so 1/3 plus a quarter plus a quarter, don't know why my pen's not working quite right. And we'll add those together. We've got a common denominator in terms of 12. So we've got 4 plus 3 plus 3. This is 10/6. Yes, the remaining probability. 10 out of 12. So the remaining probability there is 5 out of 6. And yes, that is equal to the 1 minus 5/6 is 1/6. That's another way to check that one. Last part on this really silly situation that people often make mistakes with, and it's to do with dates. If you're asked what's the probability of being born or some event happening on a day, remember this thing inside is called the event. What's happening? What are we interested in seeing happening? What's the probability of an event happening on a Friday? Well, Every week consists of 7 days. And assuming there's nothing special about that day, if it's just a random day, things like the probability that I was born on a Friday, without knowing my date or the year, probability is 1/7. If you know the year, there is a little weirdness. If we have a look at the probability of a Wednesday in 2020. Now, this is where there's a little bit of weirdness in the writing. This line says, given that the year is 2020. How many Wednesdays are there in 2020 and how many days? Well, 2020 is the leap year, so there's 366 days. How many Wednesdays are there? Well, we start on a Wednesday and we've got an extra Wednesday at the end. So that means all the way through we have 52 up to the same day we start. There are 52 days. So there's 52 Sunday, Monday, Tuesdays. And the 2 days left over, the Wednesday and the Thursday this time, because of the leap year, there are actually an extra one, there's 53. So if it's a Wednesday in 2020, we actually have a probability of 53 out of 366. This line means knowing that or given. Or knowing. Now, that's a very special case. You're unlikely to get an exam question involving that. But what you will get is what's the probability of, in a normal year, me being born in July. Now, most people will actually turn around and say the answer is 1 in 12. Just by the numbers on the calendar, this is incorrect. July has 31 days. Think back to the little quiz I've given you, the working one. There is a question which relates to the number of days in a year, or in a month in a year. Most months, years, we would say 365 generally. If you wanted to be really pedantic with it, you could actually turn around and say, given it is not a leap year. But that is an accurate answer. If I grab the calculator, hopefully it comes up. If I show you what 1/12 is, you see that is 0.833333. Show you 31 out of 65 because there are 31 days in there. You actually have 0.849. It's slightly higher. So the probability of being born in July is higher than the 1/12, ever so slightly. So this was 0.833. 0.833. Something up with my tablet at the moment. And this one, as we've just seen, is 0.80849. Slightly larger. If you were to go through other dates, you could say April. April is going to be 30 out of 365. September would be 30 out of 365. In a traditional February, you'd probably say 28 out of 365. And therefore, February is less likely. This is just purely by dates. If you have a look at the actual calendar, there are the actual dates have their own probabilities individually. Weird things happen, like Fridays and Saturdays, Sundays often seem to have peaks. This video, this graph came from Reddit, but it's an actual analysis from around the world. The darker periods show more how often people are likely to be born on those days. Down here, notice there's completely white. You can't be born on these dates because there's no such thing as 31st of November. The lighter colours, less likely to have people born. And there are plenty of reasons why this sort of pattern shows up. You can get groupings. You'd expect there to be groupings, and I'd expect some of these patterns to change over years. So maybe these sections will cycle through. But this dark band in the middle probably is fairly standard. And there's good reasons, and it's to do with this is summer in the northern hemisphere, and it's sort of, if you want to analyse why, you have to think 9 months for being born. Oh, what might people be doing in the middle of winter that will lead to there being children born in the middle of the summer? So that's the birth date one. See if you can find out what your birth date is, as well as doing the exercises that have been set. Sorry for this bit of video being longer than I intended, but if you got the gist earlier, you can probably have skipped over some of it. Thank you very much.